Solve. You will include, this is supposed to be an I, but it doesn't look like an I, does it? Make it I. It looks like an L. You will include I in your answer. You're going to have an I. So, here we go. You just solve it for x. Minus 18, nothing new so far. 2x squared equals negative 90. You can see where we're going here. Divide by 2, divide by 2. I'm going to come up here. X squared equals negative 45. Got a problem. Can't take the square root of negative 45. But now I can, because I know about imaginary numbers. So I'm going to take the square root of both sides. This cancels this out, so I have x. But I can't take the square root of a negative, but I can write it like this.
Why can't you take the square root of a negative?
Doesn't work with our real set of numbers. That's why we had to create an imaginary set of numbers. How would you ever get a square root? How would you ever find two things multiplied together? The same thing that would give you a negative. Nothing in your set of real numbers. Okay? So now I'm going to write this like this. Okay? So I'm going to write this like this. What's the square root of negative 1 equal to? How do I represent that? I represent it as I. So my answer is I plus or minus I times the square root of 45.
That's our answer?
Mm-hmm. That's it. That's it. How easy is that? It's knowing that the square root of negative 1 is I.
Yeah, we just said that.
Okay? Yeah. Oh, could we keep going? Yeah, we could keep going. And we should keep going. Thank you. Kate's paying attention. Okay? So, can I split up 45?
Yeah.
To what?
9.
What's the square root of 9?
3.
So I'm just going to write it like this. I'm going to jump right in and write it like this. X equals plus or minus 3, which was my 9.
3i?
Yep, 3i. Because I took the square root of 9. I just skipped all that. If you want to see it, it's written right here. I wrote it out here. That's the answer.
Do the notes like 4 times. Once we copy and then once we
This was from last year, but I changed it a bit. So, yeah. Okay? All right, here we go. Let's do another one. Same process. We're going to subtract 33 from both sides. 5x squared equals negative 30. Divide by 5. X squared equals negative 6. Take the square root. X equals the square root of negative 1 times the square root of 6. When I take the square root of negative 1, what do I write? Plus or minus I times the square root of 6. Not so bad, huh? Okay, that's just using the I, the imaginary number. Now, a complex number is an expression that includes a constant and an I. So we have a constant term and an I term. That's called a complex number. Complex numbers can be added and subtracted like any other terms. So, write the expression as a complex number in standard form. This is important. Standard form means that the real number is first, then the I term. And just like this. The real number is first, and then the I term. So, I'm going to see what I have here. I have a real number and a real number term. And I have an I and an I. I can combine them just like I normally would. So I got 12 take away 8, which is 4. Negative 11, add 3, which is what?
8. Negative 8.
Is the real number first? Yes. And the I term is, so this is standard form.
Is that your answer?
Mm-hmm. That's standard form right here. Not bad, huh? Okay. Now, this one's the same thing, but you got to be careful because you have a minus, which means you have to distribute that negative. Okay, you got to distribute the negative however you want to look at that. I'm going to rewrite it. 15 minus 9i minus 24 plus 9i.
What?
I distributed the negative and took away the parentheses. Distribute the negative. Okay. All right. What's 15 take away 24? Negative 9. So I did these two. Negative 9i plus positive 9i. They go away, don't they? So my answer is this. The 9i's canceled each other out. Okay, you know it gets better than this.
As in where you use your
Oh, yeah. All right, distribute this negative, and then I'm going to rewrite it without the parentheses. I distributed the negative. What does this combine to? 35 take away 13 is 23.
22.
Okay, Amanda's awake. I had 22 written right here. 22, and then negative 4i plus i. What do you get? Boom, you're done.
Can you just distribute?
If you have to. Yeah, if you have to. Okay, so this is a 22. All right, now, when multiplying, you must replace the I squared with negative 1 to fully simplify. So if it says to simplify and you have to multiply, you got to see if you end up with an I squared anywhere and you replace that with negative 1. Basically, that's all you got to do. Okay, so let's look at this. So if I'm going to distribute this, is I got to multiply. I'm going to have negative 40i plus what? Okay, you got to remember this. Remember what I told you. I squared is equal to negative 1. So whenever you have an I squared, you replace it with negative 1. And then you finish simplifying. Times negative 1. And then you get this. Negative 40i minus 45. Is this in standard form? No. So how would you write it? See how smart you guys are? You can go home and tell your parents, I multiplied with imaginary numbers today. I deserve 20 bucks. All right. Hey, we get to FOIL. Look at that. FOIL. First term is negative 32. Outer terms would be plus 56i. Inner terms would be 8i. And the last two would be minus 14i squared. I FOILed. Now I got to combine like terms. So I'm going to combine these two. And I'm going to change what? Change that to a negative 1. Okay? Let's do that all. We got plus 64i minus 14 times negative 1. Yeah? Okay, I can combine these two now. This becomes a plus 14, doesn't it? Yeah? You see it? Okay, so it's going to be negative 18 plus 64i. These two I combine together. And there's your answer. Sweet, isn't it? All right, you do this one. On your own, real quick. Try it. Is that what you got? Did you write it the right way? Okay, cool. Here we go. Oh, look at, there's that word again. Complex conjugates. All right. So much excitement over imaginary numbers. Two complex numbers of the form a plus bi and a minus bi. The product of the conjugates will always be a real number. The i's cancel. The i's cancel. When you multiply conjugates of imaginary numbers, you're always going to get a real number. So, if I have to solve this, what am I going to multiply to clear my denominator? 5 plus I. 5 plus I. Boy, there's a lot of room here. Maybe for a reason. Okay? It's not that it's that hard, it just takes up a lot of room. So let's do, what should we do? The numerator first? We're going to FOIL the numerator first. So FOIL that numerator. It's going to be 15 plus 20i. You may go in a different order than me. It's okay if you do. Here's my numerator, FOILed. I'll simplify it in a minute. We'll simplify it in a minute. Okay? Let's do the denominator now. Conjugates, same as yesterday. Don't have to worry about a middle term because there's a plus and a minus. You just got to multiply the first two terms, which would be what? 25. And the last two terms, which would be what? Minus I squared. Let's just write it like that for now, and then we'll fix it. So I have two I squareds here, don't I? I'm going to keep track of. They become -1. So let's make this pretty. So my numerator, I'm going to put these together. So I'm going to have 25 plus 23i. What does this become? -4, right? 15, sorry. 15 plus 23i minus 4 over, what does the denominator become? 25 plus 1, which is 26, because this is a -1. 25 minus a -1 is 26.
Is that our answer?
Not quite.
Oh,
What can we finish with now?
11.
We got to combine 15 minus 4. 15 minus 4, which is 11 plus 23i over 26. Now we're done. I squared is -1. Okay?
You're not done yet.
You want to try this one? On your own?
Yeah.
Try it on your own.
Yeah, seriously.
Okay, so here, this is all you do, is the x-axis becomes the real number axis. The y-axis becomes the imaginary term axis. So it's really quite easy, actually. This gives you a point. It gives you a point. And I'll show you what it is. The first number, that is the real. Obviously, that's your real coordinate. And this is your imaginary coordinate. So you just look at the numbers. And so we're going to graph A here. What this means is I go over 4 on the real axis and up 2 on the imaginary axis, and that's point A. Is that like way easy or what?
Oh my god, right?
Yeah. All right, so let's plot B. The real is -1, so I go -1 and up 3. There's point B.
That's so easy. I love it.
It is. Okay, now be careful with this one. Is this the real term or the imaginary term? So what's my real term?
0.
So you have to think of it like this. Over 0, and then what? Down 4. Over 0, down 4. Okay, over 2, down 2. There's D right there. Okay, almost done. Shh. Oh, we have to talk about absolute value.
What?
Absolute value of a complex number. This looks way more complicated than it really is. Yeah, it's really easy though. If you have this complex number right here, A plus BI, I'll wait. Then the absolute value is a non-negative real number defined as this. So look, all you're doing here, I wish I had a highlighter, but I don't. You see A here? All you do is you write it squared. You see B here? All you do is write it squared. And you've written the absolute value. Don't ask me why it works that way right now. I haven't figured that out, but let's do it. Let's just do it. Find the absolute value of this complex number. Well, this is A, and this is B, isn't it?
I guess.
And the absolute value says all I have to do is square A. So I'm going to square A, which would be 5 squared. Add to it the square of B. I didn't put something in here. I need to fix that. Add to it the square of B. And there's a very important thing missing here. I apologize.
Wait, 5 squared what?
There's supposed to be a square root sign over here.
Oh my god.
Oh my word! It's a good thing you guys never forget anything.
Oh, that's like,
It's over this.
Oh, it's 13.
It's the square root of A squared plus B squared. So when you do this, you get 25 plus 144, which is the square root of 169. So what'd you say? Somebody say 15? Oh, it's 13. So the answer is 13. The absolute value of Z is 13.
squaring something and taking the square root of it, so it's
No, because you have to add them together first. Okay? You got to do everything underneath there first. Okay, let's do the same thing for this. We have 0 plus 17i. This is A, this is B. So you just set it up again. Obviously squared, that's not going to do anything. 17 squared, and this is where what Irene just said is going to come into play, basically. It's just 17.
Obviously.
So why is it just 7?
Okay? Hey, are you